Hi, I'm Daniel Chan from UNSW Sydney. This is Extension 3 Mathematics for Talented High School Students. In this video, I want to tell you about Catalan numbers, which occur in many enumerative problems. So the enumerative problem or counting problem that I want to tell you about today is the following one. What we're going to do is we're going to look at an expression like this, a string, x1, x2 up to xn. And we'll consider this as something that we can form by multiplying consecutive terms together. But one of the things that you want to do is that when you multiply them, you have to say, well, which ones do you multiply first? And the way to do that is you bracket them. And what I want to say is that if you have this string of n variables here, x1 up to xn, let un be the number of ways of bracketing it. What's the answer? So let's have a look at some simple examples. So let's have a look and see what happens when you have three variables, u3. Okay, u3 I claim is equal to 2. And why is that? So if you have x1, x2, and x3, you can multiply the x1 and the x2 first, and then do the x3 last. If you like, you can put the brackets around like that. Or you can multiply the x2 and x3 first, and then do the last multiplication like that. Okay, so let's look at something a little bit more complicated. u4 I claim is equal to 5. So why is that true? So you can have x1, x2, x3, x4. You can multiply the x4 last, in which case you've got two possibilities for multiplying x1, x2, x3 corresponding to these two. You can multiply x1, x2 first, then multiply by x3, and then x4. I'll drop the last bracket. Or you can do x1, but you do x2 times x3 first, and then x4. Similarly, you can, instead of making x4 the last one you multiply, you make x1 the last one you multiply. And then the last three, you can either do x2 and x3 first, and then x4. Or you can do x3 and x4 first, and then x2, and then the last one. And what else can you do? Okay, so I've got four possibilities here now. So the last thing you can do is you can multiply x1 with x2, you can multiply x3 with x4, and then you can multiply those two products together to get you the fifth possibility. And so the question is, well, how does this sequence change or vary as you increase the number of brackets here by increasing the number of variables that you have here? So to do this, what we'll do actually is that we'll define this even when n equals 0 by some default values, and you'll see later why we have these default values. Okay, so the default values will be when n equals 0, u0 equals 0, and when n equals 1, u1 is equal to 1. So let me tell you how to answer this question. And the way I'll do it is it's kind of similar to what I've done over here. How did I split up the possible ways of bracketing this here? So what we're going to do is consider the last multiplication. So what's the last multiplication involved? So you're going to go x1 up to xj, and then xj plus 1 up to xn. So in this case, these first two here, we have x4 is multiplied by the first three. Okay, so first three times x4. In the second two, we have x1 times the last three, x1 times the last three. And in the last one, we have the first two is multiplied by the last two. So the last multiplication that has to take place is always you'll somehow bracket the first j times somehow bracketing the last n minus j. And so what's the total number of ways of bracketing if this is the last multiplication? Okay, if that's the last multiplication, the total number of ways is uj times un minus j. And of course, you can have this for any j. So I'm going to write this as, so if you want to bracket this n terms, the number of ways is you sum this up for all j. And well, what are the, where can j go to and from? So I'll go from 0 up to n. Turns out that you can do that. Okay, and part of the reason why this is allowed is because we've set u0. Okay, so you may think, well, surely you should only go from j equals 1, right? But I said that u0 is equal to 0. So if I throw in the j equals 0 term, that's fine, because that's only going to add a 0 to the sum. Also, when j equals n here, n minus j here gives you 0, so there's a u0 term, so that's fine as well. Now what we're going to do is we're going to use generating functions to try to understand what is this un, and also this here is a type of recurrence relation. Okay, it's a more complicated recurrence relation than some of the others you might have seen, but still it's going to tell us essentially what un is in terms of the previous ones, because the only time that un occurs here will be when j equals 0 here, in which case there's a 0 term, so it doesn't really occur, or when j equals n, okay, in which case this is 0, so that doesn't really occur. So it's going to tell you in terms of previous things. So it's a recurrence relation. And the best way to work with recurrence relations, of course, is to use generating functions. So that's what we'll do. So what we'll do now is we're going to let ux is going to equal the sum from j equals 0 up to infinity of u n x to the n. That's your generating function. Of course, when j equals 0, u0 is 0, so actually it starts at, so that's n there, sorry. So it starts at n equals 1. But we'll write it like that because that's the general form. Okay, so let's have a look and see what's going on here. So this is equal to what? So I guess the other thing that you should notice that for what values of n is this true? I guess when we split it up, you better have at least 2 terms. So this is for n greater than or equal to 2. And what do you have here? Let's just write down the first few terms. You'll have a 0 plus x plus the next term will be the u2 term, u2x squared plus dot dot dot. Okay. Now what we're going to do is we're going to use this relation, and this tells us something about the generating function. In fact, of course, hopefully you can see that these are the coefficients that you get in the Cauchy product. So let's have a look at ux squared, okay? U of x squared. What's that equal to? So basically, this is going to be given by, well, you're going to square this, so the first term will be x squared term, and we know from this formula here that the coefficients, once you go from the x squared term on up, okay, those coefficients are precisely what's given here, okay, by the UNs, okay. So this here corresponds to u of x squared, okay, and the coefficients of this when n is greater than or equal to 2, okay, so those values are the same as un, which is just u of x. So that means that this is just u2 of x squared plus dot dot dot. And now what you can do is you can do this one minus this one. So u of x minus u of x squared is equal to x. And that is equivalent to, well, now what you have, I'll drop the u of x, the function, so I'll just write u squared minus u plus x is equal to 0. So I'm going to bring everything over to the right-hand side. And what you'll find here is that you have this generating function, u, satisfies some quadratic equation. And now you just apply the quadratic formula to determine what u is. So therefore, u is equal to, so the quadratic formula, so you have the negative of this coefficient of u, that's 1. And now you have a plus or minus, and then you have the square root of the square of that, so that's 1, minus 4 times the coefficient here, which is 1, times the constant term, which is x, minus 4x. And you divide by 2. And that's your answer. And now this is a little bit funny because you see 2 solutions here, but of course you shouldn't have 2 solutions. This is a unique power series that's given to you. And so what you will do is that you'll have to pick which of these is the correct answer, the plus or the minus. But it's very easy to see which one it will be, because if you look at the expression for what this will turn out to be, when you look at the terms, of course, you'll get two possible answers once you work out what this is. And one of them will definitely have all the coefficients being non-negative. In fact, they'll be positive after the 0th term because this is the number of ways of bracketing this expression, so they'll all be positive. Turns out if you use the other one, you won't get that, so that will tell you which one it is. And now the only question that you need to know is, how do you work out what is the power series that's representing this? Unfortunately, well, the only thing you need to know is how do you work out what is the square root of 1 minus 4x? And that's something to the power of half, and so you can use the binomial series to work out what that is. And let me just tell you what the answer will be. And if you don't know about the binomial series, you can look that up on the activity sheet in the extension 3 mathematics, the one involving power series. So we use the binomial series here. And this will tell you what the answer is. I'll just write down the answer. It's going to be un is 1 on n, 2n minus 2, choose n minus 1. And that gives you a beautiful way of using generating functions to answer this rather complicated counting problem. I hope now you can also use generating functions to see how Catalan numbers appear in lots and lots of other counting problems.